So if you would, please give a hand for Professor Pope.
Thank you very much. Before I start, I'd like to congratulate Peter and his colleagues on organizing a wonderful conference. It was never going to be difficult, I guess, to get 150 academic accountants to a winery, but it's a wonderful occasion, and I very much appreciate the invitation. What I hope to do in the 10 minutes or so allotted to me is to focus upon some ideas I think we might take on board in trying to integrate the empirical work on valuation with model building and development in model building. And picking up on what Jeff was indicating or suggesting in the first presentation, I think forecasting and focusing on the links between forecasting and valuation is going to be an important part of that process. So just a quick recap on how I organized my thoughts for this session. Why are we doing these valuation models? Why are we trying to build them? There's a bunch of different clientele groups out there, researchers, perhaps regulators, depending on your viewpoint, investors and issuers. And they're interested in a variety of different questions that might be asked of valuation models. I won't go into those in detail here. But the common interests are essentially in understanding the conditional distribution of both current prices and potentially future prices or returns, conditional on financial statement information and other information that might feed into our valuation models. And moreover, we may be interested in understanding the marginal effects on price of changes in accounting inputs, which of course should come out of a well-built valuation model. So what I'm going to do first is just make a claim that I think most, if not all, users of FSA models might be able to agree on. Firstly, that we would like a model which has the property of yielding unbiased prices. It gets it right on average so that the expected value of forecast errors from a pricing model should be zero empirically. Secondly, I think that one of the properties that Jim and others have built into these pioneering valuation models, the property of no arbitrage, is an intuitively appealing property that a model should satisfy. Now, we talk about the use by analysts, by investors of models, believing that they can identify mispricing. I don't think there's any inconsistency between a model pricing correctly on average and the use of these models in detecting alpha in the investment world. There may be mispricing, we may be able to exploit it, and it may be uncoverable on the basis of a well-built valuation model. And a third property which may or may not achieve consensus would be the notion of dividend displacement on prices or dividend irrelevance in the M&M type assumption that we see in many models. So price changes with respect to dividend payout by some constant, negative constant, let's call it -1 for the sake of argument. We may wish to argue about what the value of C is depending on taxes and other potential factors. Now, one issue here is that dividend irrelevance does imply some restrictions on valuation coefficients, for example, with respect to the book value and dividend coefficient, if that's in your model. So what I've done here is classify models into two main model building approaches. On the left-hand side, we have an information set, we have some assumptions, they map into a valuation expression, and the model has some properties. And what I've called type 1 here, which we all know and love through many papers that have been published over the last 10 years, would take the dividend discount model as a starting point, as the first presentation indicated. It would add on some further assumptions called clean surplus relation and information dynamics, and result in a valuation expression or expressions. So in the case of Olson 99, we have book value, residual income, and other information, or an analogous weighted average expression involving book value, dividends, and net income, and other information. From that model, we can detect or identify some economic properties. For example, dividend irrelevance and dividend displacement properties, as Jim discussed in his paper. An alternative approach is to start with some economic property assumptions of a model. Dividend discount model, clean surplus relation, fine again. And, as the first presentation said also, some valuation form. Linear valuation. Price is a linear function of the accounting inputs and potentially other inputs. From that, we get valuation expressions, and we also get implied information dynamics. So in type 1, information dynamics are an assumption. In type 2, the information dynamics are an implication of the model setup. We may also get some results on conditions for the irrelevance of an accounting item in valuation or the aggregation properties of accounting items. Now, why might this modeling approach matter, or why might the choice of modeling approach matter? In the first case, the information dynamics structure will be sufficient, certainly, but maybe not necessary for the economic properties to hold. In the second case, you may get more general information dynamics which are capable of supporting the pricing model form and the economic properties of the model. When we do reverse engineering of model parameters from prices, then one thing we can do is infer the information dynamics parameters, but we may also be able to infer or back out of prices the information dynamics structure as well. And this could be important when we're using models for assessing mispricing, which has to be conditional on information dynamics assumptions and the implied cost of capital application of models as well. Now, so far the link between theory and empirical testing of such theories the evidence is fairly scarce. We have some evidence that shows that intrinsic value models underprice, or they produce biased price forecasts, and this, to me, may mean that there is a misspecification in the intrinsic value model if you condition on an assumption of efficient markets. It could be due to, for example, the incomplete modeling of accounting conservatism. There is also at least one paper I know, but very few, which actually directly attempt to test the consistency between valuation model parameters and those that would be implied from an information dynamics structure. So Barth, Beaverhand, and Landsman in the 99 paper show that conditional on an assumption of market efficiency, they show that, firstly, that the information dynamics constraints, parameter restrictions, are actually binding on the valuation parameters, suggesting that perhaps there is, again, misspecification in the information dynamics which yielded those restrictions for pricing parameters. There's also, finally, quite a vast literature, value relevance literature, let's call it, which indicates that accounting components of both net income and book value attract different valuation weights. Most models to date have not attempted to focus upon components of book value and or earnings. But recognizing different valuation weights and recognizing there's a link between forecasting and valuation suggests that there is potentially a complex real structure of the information dynamics for forecasting, let's say, residual income and for intrinsic value estimation. So I'll just give you one example to close here. This is taken from the Pope and Wang paper in 2005. If you start with a linear valuation expression as an assumption of the model, and then you bolt on no arbitrage, and by the way, a lot of people think that because a valuation model is derived from the dividend discount model, which is a no arbitrage model, that we therefore must necessarily have no arbitrage property in the pricing model. That's not true. It depends upon the information dynamics as well and whether that's consistent with no arbitrage. And that's the point of this third expression here. If you bolt together the valuation expression, no arbitrage, clean surplus, and dividend displacement of prices, the M&M assumption, you get an abnormal earnings dynamics which look like the third expression on the fourth expression on the slide. In that, you can see that the Olson 95 abnormal earnings dynamics is a special case. But there are other terms in there. The second term with omega-2 reflects the possibility that earnings components don't aggregate in valuation. And the third component with the omega-3 parameter reflects the possibility that accounting is biased or conservative. So we end up with an abnormal earnings dynamics which is more general than the Olson model, but which has exactly the same economic properties as the Olson model. And that's underlying my point about assuming an information dynamics will give you a sufficient set of conditions for valuation and economic properties, but they may not be necessary. So the bottom line message then is that we can't really simply focus on abnormal earnings alone in a model like this. You can see, importantly, in the second term of the earnings dynamics there, that expectations of X2 also appear in the abnormal earnings dynamics. So the forecasting problem from the point of view of someone wishing to implement a valuation model becomes more complex. We can't just focus on one target variable, abnormal earnings in this case. We may need to focus upon an earnings component, which is itself forecastable. So the bottom line of my message is that whilst we are chasing after theoretical valuation models that map information into prices through a forecasting model, the properties that we assume in the model building are important, the assumptions that we make are important, and a model will be successful according to my criteria if there is consistency between the forecasting and the valuation parameters. The fact that the few tests we've seen to date reject the forecasting parameter restrictions in empirical tests of valuation suggests that we haven't yet got the forecasting, the information dynamics models correctly specified. And I suggest here just a few ways in which we can detect with empirical work the need for possible further model development to force some consistency between the forecasting problem and the valuation problem.